Good morning, everybody. Welcome to another session of Verilog HDL. In today's session, we'll start off with Verilog HDL, in which we'll be looking out for overview of digital circuit design. So, in previous this thing, we had discussed a few of the concepts which will be utilized in the forthcoming discussions. That is, we saw what is the overview related to the logic design which is required for digital circuit designs, and then we came across with the introduction of HDL, then how Verilog came into existence and VHDL came into existence. What are the comparisons between Verilog, HDL and VHDL? So these are things we discussed, and then few important things what we came across was the different levels of abstraction or design description what we provide. That is switch level, then we had gate level and behavioral level and data flow levels of abstraction. And we saw few simple examples related to those. And lastly, we discussed what are few of the say constructs and conventions what are followed in HDL or Verilog, what we had discussed. So now let us start off with the next part, that is the design overview of digital design. So in this first thing, what we have to just look out is what is the evolution of computer aided digital design. So in short, sometimes it is termed as CAD. Computer aided digital design is sometimes in short formed as CAD. So in this one, we can just see that digital circuit design has changed rapidly in the recent years, in which we can see that we have come in from say a small scale integration to large scale, medium scale, and say very large scale integration. So this has changed in recent years. Now devices used for digital circuit designs are have also evolved in such cases. Now, in previous this thing, digital circuit designs were made use of vacuum tubes, transistors, and later came the ICs, that is the integrated circuits, which basically consists of the say logic gates, which are placed on a single chip. Then under this ICs itself, there was a large number of evolution which have happened. That is the first thing which comes as a small scale integration, which is sometimes termed as SSI. So which had a very few number of gates on a single chip. Say it was less than 100 gates which would be placed on just a single chip. Then there were advancements in this one, that is in terms of how many gates I could place on a single chip. So next came the medium scale integration, that is MSI, in which hundreds of gates could be placed on just one single chip. So similarly, we could as the advancements went on, we could place a large number of gates on a single chip. That is next came the large scale integration, in which thousands of gates could be placed on just a single chip, and then came the very large scale integration. So in large scale integration, what happened is previously we could just observe that only a few number of gates were present on a single chip. So if the circuit is simple enough, just few number of gates are used, we can go ahead with the design process in a much simple way. But if I keep on increasing the number of gates on a single chip, or if I keep on increasing the number of gates which can be used for the design of digital circuits, then what happens is we are increasing the complexity. So if you just observe here, it was just say less than 100 gates, so design was simple. So here it turned out to be up to hundreds of gates we could place. So still comparatively the design was simple, but when it increased to when it came to large scale integration, so that time thousands of gates which could be placed on a single chip gave rise to increased complexity, which was related to the design process. So this is where computer aided design came into existence. So this could help us in order to automate the processes like placing and routing of the say netlist what we are getting, and obtaining a optimized design. So that is so these are just a few things to name. So computer aided design involved because of the complexity what was increased in the overall design process. So next, in that, the chip designers also started to simulate the circuit and the logic. This thing. So for this also, we had some simulation tools which were available. Now these simulation tools, which were used to simulate the circuit and the circuit and its logical implementation, they were basically used to test the functionality. They were used to test the functionality. It may just not be just the building blocks, but entire thing. So if I have one big chunk, I may be building this big chunk with smaller building blocks. So to test the functionality of these smaller building blocks and also the overall functionality. So this is where simulation came into existence. Now here we had another this thing, but what was the challenge in this one was large scale integration. Now still the circuit testing, it was done on breadboard. So you can just imagine what might be the level of complexity when we are dealing with the breadboard. So now here it is not the overall ICs what you're placing in one IC itself, you might get the entire functionality what is intended. So this IC will be placed on the breadboard, and then it can be tested along with other components, say interfacing components, and you can test it out. So this testing was still done on breadboard. You can imagine what amount of time has to be put in to test the circuits what were built using this LSI. But later there were tools even wherein we could just try to see what the entire thing can do without going for breadboard. So this is the evolution related to the ICs. So apart from this, we had even large scale integration, very large scale integration. Now another thing to consider in LSI is layout was done on paper and by hand in the graphic terminal, computer terminal. That is, if you had to bring out the layout, right? So still you had to do it manually. If you have to bring out the layout of the system, so if the system requires a AND gate or gate, then any other block. So these all things still they had to be done using they were done on the paper, or they were done manually using the graphic computer terminal. Now next came very large scale integration, which is sometimes termed as VLSI. Now in this, what happened is the number of transistors that could be placed on a single chip got increased from say thousands to hundred thousands on a single chip. So now here you can see the amount of complexity is still increased with respect to the design process, and because of which again CAD tools had to make some improvements in order to cater to very large scale integration. Now apart from this, verifying these circuits on the breadboard itself becomes a very big challenging aspect. It is because of the complexity what is present. Now when we are speaking of these things, then your CAD tools had also to evolve in these cases. Now this is where CAD tools became very critical. Not only from say the other point of view wherein we are just trying to implement say using the RTL code and trying to get the stuff. Apart from that, even verification also you are looking forward. So this is what we are looking forward for. So you can just see what all changes were done. So previously your digital circuit design was done by hand, and